Okay, we're going to be discussing prisms and pyramids in this video, and again we're going to be talking about volume and surface area of these 3D figures or polyhedrons. Okay, so a prism, okay, if you remember when we talked about the definitions, we said that it's got two bases, and remember those bases must be congruent and parallel to each other. Okay, it's also got parallelogram faces. So all of the sides, other than the bases, are going to be parallelograms. So if you look at this first example down here, the back of this figure would have another triangle, like this purple one. Okay, and if you can picture this left side and the bottom, those would all be quadrilaterals or parallelograms. Okay, so this would be a triangular prism, because you name prisms by the bases, and the base, there are two triangles, and then there's going to be three rectangles. So this is a triangular prism. Okay, this next figure, okay, if you can see, all of these sides are rectangles. Those are the faces, the lateral faces. The two sides that are congruent and parallel, which are these on front and back, okay, this has 1, 2, 3, 4, 5, 6 sides. So that's a hexagon. Okay, so this would be a hexagonal prism. And last but not least, we have this one that has the 4 rectangular faces and then 2 square bases. So this would be a square prism. Notice, just because the bases are squares, it does not mean it's a cube. A cube would have to have all of the faces and bases equal. Okay, so this one doesn't, because these are rectangles, only the base are squares. Okay, and notice that even though this is considered the base, this purple triangle, it's not sitting on the triangle. Same thing with this hexagonal prism. It's not standing up on the hexagon. Okay, so don't let the term base make you think that the base is what it's sitting on, like in this square prism. It doesn't have to, it can sit on any face. So here are the formulas for lateral surface area, total surface area, and volume of prisms. Okay, you need to make sure you realize what these letters stand for. P, okay, it's a capital P, is perimeter of the base. So you'll have to know your perimeter of your base, and the capital B stands for area of the base. So you definitely need to identify your bases, and then you'll have to find the perimeter of one and the area of one. And of course, H is just the height. Height in a prism is the distance from base to base. In this example we're about to work, if the triangles are the bases, which they are because those are the two polygons that are congruent and parallel, okay, so the triangles are the bases, this would be considered the height, and it's not up and down, okay, so don't get in that habit of thinking it has to sit on the base and the height has to be up and down. Okay, the height is the distance from one base to another. We'll start with the lateral surface area. Okay, so perimeter of the base times the height of the prism. Okay, so first I'm going to come off to the side and find perimeter of my base. My base is a triangle. Perimeter just adds all of the sides. So we have a 4 and a 5. We don't know what this side is. We need to solve for it before we can get perimeter. And this angle is marked as 90 degrees. So in a 90-degree triangle, when you know two sides, you may find the third using Pythagorean theorem. In this case, we don't have to do it if you've memorized your Pythagorean triples. Okay, this is going to be a 3, 4, 5. Okay, if you did not remember a 3, 4, 5 is a Pythagorean triple, you have to actually work out a squared plus b squared equals c squared, and when you solve, you should get 3. So the perimeter is going to be 3 plus 4 plus 5, which is 12. So my P is 12. And the height is given in the picture. The distance from base to base is 8.5. So my lateral area of my prism And remember, we said lateral is everything except the bases. So that's 12 times 8.5 is 102. And these were measured in centimeters, and you know that area is units squared, so centimeters squared. So that is the area of the 3 parallelogram faces. Okay? And then we will do total surface area, which is going to be pH, that's the lateral area, plus the 2 bases. Okay, so we've already found pH, and that's 102, so I can simply plug that in. And then I have 2 bases, that's why there's a 2 here. There's 2 triangles. So I need to find this capital B, area of my base. This is a triangle. Area of a triangle is 1/2 base times height. Now realize the capital B is the area, the lowercase b is the base of the triangle, the base of your base, you could say. Okay, so in a right triangle, the base and height have to meet at a 90-degree angle. So that's going to be the 4 and 3. So 1/2 times 4 times 3 is 6. Okay, so my capital B, area of my base, is 6. So I'll plug that in here. So I have 102 plus 12. So my total surface area is 114. Still talking about area, so units are still just squared. Okay, so lateral and total. Now we can find the volume. Okay, volume is the area of the base times the height. Okay, we've already found area of our triangular base to be 6. So B is 6, and the height, not the height of your base, remember this H refers to the height of the prism, so that's 8.5. So you do 6 times 8.5 to get a total of 51. So 51, and volume units are cubed. Okay? Now let's try pyramid. Pyramids, remember, the way they differ from a prism is that they only have one base, and all of the faces are triangles. Okay, so here, this base is a triangle, so this would be a triangular pyramid, because we name them according to the base. Triangular pyramid. Okay, this pyramid, the base has 1, 2, 3, 4, 5, 6, 7 sides. So that's a heptagon. So this would be a heptagonal pyramid. And last but not least, notice this isn't sitting on its base, but we know that all of the faces come to a common vertex called the apex. So this is the base here, and it's got 1, 2, 3, 4, 5 sides. That's a pentagon. So a pentagonal pyramid. Okay, so that's how we name our pyramids. Here are the formulas for lateral and total surface area as well as volume. And I've got a picture here labeling H, L, and B. So notice this is a capital B. So they're saying the area of this entire base. That's the capital B. Okay, the height is what makes a 90-degree angle with the base. If I were to draw a line out on the base to the edge here, okay, that's going to be a 90-degree angle. That's your height. The L, remember, stands for slant height, just like in a cone. So the slant height, you'll notice, is down the side of a face. It's not the actual edge where two faces meet, these black lines, okay, but it's down the side of the face to make a 90-degree angle with the bottom edge. Okay, and I've got this colored picture here to help you see it a little better. So the base is this red shape or polygon at the bottom. Okay, the height is going to be vertical, okay, or perpendicular to the base. Okay, so straight up and down, or you can draw it in the center like in this one. And the slant height is slanted down the face of the pyramid. Okay, and then of course that common vertex we call the apex. So let's try this example. This example gives us 20 by 20, so that's telling us that this is a square pyramid. So the base is a square, so when we go to look for capital P and capital B, okay, we're talking about perimeter of the base that's a square and area of the base that's a square. So I'm going to go ahead and find those first. So capital P is perimeter. So a square has 4 congruent sides. So it's 20 plus 20 plus 20 plus 20. Or since it's a square, I can just say 4 times 20. So that is 80. And area of my square, area of a square is side squared or base times height of the square. So that is 20 squared. So now we have all the variables needed to answer these questions. So I will first do lateral area. So that is 1/2 perimeter of the base times the slant height. That is 1/2. We said P is 80, and slant height was given to us as 26. So half of 80 is 40 times 26 is 1040, 1040. This was we weren't given measures here, so we'll just say units squared. Okay, then for total surface area, we take the lateral, remember we already found that, it's lateral plus the base, because total surface area is all the faces plus the base. So I've already got my 1040, and I need to add B, which is area of my base that I found to be 400. So 1040 plus 400 is 1440. And our units are still squared because we're still referring to surface area. Okay, and last but not least, then we need to find our volume of the pyramid. Do that right over here. So volume is 1/3. B, area of the base, 400, times the height of the pyramid. My height is what we found using Pythagorean theorem, and that is 24. So 1/3 times 400 times 24 is a grand total of 3,200. And our units for volume are cubed. Okay, and you may sometimes be asked to work some of these backwards, like we've done in the past with cylinders and cones and spheres. So you could be given the volume and asked to find the height, okay, and you could work it backwards using your algebra skills. Here are 2 problems. I want you to try them on your own. If you come across questions or are unable to do these, you can come and see me.